Let's say that we're doing troubleshooting or for some reason we need to monitor network traffic coming into and or going out of a specific port on a switch. Well, a challenge we're going to have is a switch is going to be making forwarding decisions based on destination MAC addresses. So if server 1 and PC 1 are communicating between themselves, the frames that are part of that conversation, they don't show up on any other port. So if I plug my network analyzer, maybe a laptop running Wireshark into gig 0/2, I'm not going to see the traffic going between the server and the PC. The good news is I can enable a feature called SPAN, Switched Port Analyzer, where I can define a source that I'm monitoring. It might be one port, it might be multiple ports, it might be an entire VLAN, and I can specify the destination port out of which I want to send copies of the traffic that I've seen on the source, and I can connect my network analyzer to that destination port. And now when the server and the PC are communicating with one another, the traffic is going to be copied from gig 0/0 going into and or coming out of gig 0/0, and a copy of that traffic is going to be sent out of gig 0/2. And in this video, we want to discuss three different types of span. There's local span, remote span or RSPAN, and encapsulated remote span or ERSPAN. Let's begin by discussing local span, and that's what we have just seen demonstrated, where the source port and the destination port, they're on the same physical switch. And even though in this example I'm monitoring a single port, I could also be monitoring multiple ports or traffic in an entire VLAN. One important thing to remember, though, is that this destination port, it's going to become dedicated to monitoring. It's not going to be able to be used for regular data traffic. So local span, we have the source and the destination on the same physical switch. However, it might not always be convenient to travel to that switch that has our source port or ports or source VLAN on it. Maybe I have my network analyzer connected to switch SW2, but I'm wanting to monitor traffic going into and coming out of gig 0/0 on switch SW1. How could we possibly do that? Well, we can do that using RSPAN or remote span that's going to allow us to monitor traffic across multiple switches. And here's the way that works. We're going to create a VLAN that's dedicated just to carry this RSPAN traffic. And we're going to have a trunk between our switches, and that trunk is going to carry traffic from multiple VLANs, including this special RSPAN VLAN we just created. Let's say that it's VLAN 900. And we're going to configure both switches SW1 and SW2 for RSPAN. From the perspective of SW1, the source is going to be port gig 0/0, and the destination is going to be this RSPAN VLAN of 900. And from the perspective of SW2, the source is going to be that RSPAN VLAN, and the destination is port gig 0/1, which goes out to our network analyzer. And this might be a great solution for monitoring traffic, let's say in a campus environment. But there is a limitation to RSPAN, and that is it is layer 2 only. In other words, our switches need to be in the same broadcast domain. We need to be able to have an Ethernet trunk between those two switches. But what if I want to monitor traffic that is on a different subnet than my network analyzer? Well, that's where ERSPAN comes in, or encapsulated remote span. It allows us to monitor traffic across a layer 3 or a routed network, maybe in a different subnet on our own campus, maybe at a remote site, maybe over the internet. And the way ERSPAN breaks through the layer 2 limitation is it encapsulates traffic inside of a GRE tunnel or a generic routing encapsulation tunnel. And packets flowing across that GRE tunnel, they have a source and a destination IP address. That means they're going to be able to be routed across our network just like any other data traffic. And from the perspective of switch SW1, the source is gig 0/0 connected to our server, and the destination is an ERSPAN ID. And there's going to be a bit of configuration to define what that ERSPAN ID of 100 means. We're going to say that we're going to a destination of 10.2.2.2, and we're sourcing traffic from 10.1.1.1. From the perspective of SW2, the source is ERSPAN ID 100, and the destination is gig 0/1 going out to our network analyzer. So this is going to give us some incredible flexibility. We're going to be able to monitor traffic in one office and analyze it in another, or maybe even send our traffic to a cloud-based monitoring service. Now let's recap these three different flavors of span. Local span, that's perfect when everything is on one switch. It's a quick and simple way to monitor traffic. RSPAN is going to extend that capability across multiple switches in a layer 2 network using a dedicated RSPAN VLAN, and ERSPAN, that's going to give us the most flexibility by using GRE encapsulation across a routed network. In each of these varieties of span, they each have a place in our network monitoring toolkit, and the key is to understand your monitoring requirements and your network topology, and then select the right tool for the job.